So in this section, we're going to be talking about events that involve not, events that involve or, and how we can understand or use odds. Okay. So first, let's go ahead and discuss our basic idea of an event not occurring. Okay. So this is the probability of not E. This is also sometimes written as the probability of E complement. Okay. When we're dealing with the probability of E complement, or the probability of not E, this is the same thing as 1 minus the probability of E. Okay. That's because an event and not that event form what are called relative complements to one another. That is to say, if we take them together, then they form our entire sample space. Okay. So let's see if we can find out what is the probability that I don't draw a heart if I'm given a deck of 52 cards. Okay. Well, this is the same thing as 1 minus the probability that I do draw a heart. Okay. So it's 1 minus, well, we know that a fourth of the deck is hearts, so it's 1 minus 1/4, or 3/4. Okay. Hopefully that makes sense to everybody. Now, this also can be used in ways that seem like they may not apply directly necessarily. So, for example, if you are attempting to determine whether or not something won't happen, or if something happens at least one time, so let me just write this here. The probability of at least 1 is the same thing as 1 minus the probability of none. Okay? So sometimes they'll be asking you, finding what's the probability that you get at least this thing, and to determine that, you first find out what's the probability that it doesn't happen, and then take 1 minus that. Okay? So this is just a clever way of making use of complements. Okay? Let's do another one. Sticking with our playing cards here, what's the probability that I do not draw a picture card? Okay. So not draw a picture. Okay. So first, we'll note this is the same as 1 minus the probability that I do draw a picture. So we have 1 minus, well, how many picture cards are there? There's Jack, Queen, and King. So that's 3, and then for each suit that gives us 12 out of 52. Okay. Now you'll note here this is 1 minus these share a factor of 4. This is 4 times 3. This is 4 times 13. Cancel these. So this is 1 minus 3/13. Okay. Now note that 1 is the same as 13/13. So 13/13 minus 3/13 is 10/13. Okay. So the probability that I am not given a picture card if it's randomly dealt to me is 10/13. Okay. So now let's go ahead and discuss how we can find the probability of things that are dealing with OR. Okay. So when we're dealing with OR, we need to first discuss the concept of mutual exclusivity. Okay. So two events are said to be mutually exclusive if they cannot occur at the same time. Okay. So two events are mutually exclusive, and I'm going to call these A and B, are mutually exclusive if it is impossible for them to occur simultaneously. Okay? Hopefully that makes sense to everybody there. So they are mutually exclusive if you can't have both of them at the same time. Okay. So if you look at that, then if I want to find the probability of A or B, okay, the probability of A or B is the probability of A plus the probability of B. Now you'll note that when you see the word or, that should kind of make you think of union here. Now remember, if we wanted to find the cardinality of the union, we added up those cardinalities and then subtracted their intersection. So this definition works for mutually exclusive, but it's not the one that I really want us to remember. Instead, the one that I want us to remember is that the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Okay. Now, the reason why I prefer this formulation is that, well, if two events are mutually exclusive, then what's the probability of A and B at the same time? Well, in that case, the probability is, or the intersection between them is 0. Okay, so if you're wanting to get this, you can just use this formula in noting that if this is 0, then it's just this. Okay, hopefully that makes sense. So now, let's go ahead and take a look at some examples here. Make sure that we can get a nice intuition or foundation. Okay, so let's suppose that I am rolling dice. Okay, I want to know what is the probability that I get an even number or a number greater than 3. Okay? So this is the same as the probability of an even number plus the probability that it's greater than 3 minus the probability that it is even and greater than 3. Okay? Well, if I'm rolling a 6-sided die, the probability that it's even is 1/2. Plus, now I'm actually going to rewrite this. Instead of 1/2, I'm going to write 3/6. The reason why I do that will become apparent in a second. So the probability that it is greater than 3, well, 4, 5, and 6, that seems like it's 3 out of 6, minus how many numbers on a 6-sided die are even and greater than 3? Well, there's 4 and 6, so that's 2 out of 6. Okay. So to find my probability, I'll just add these up. So 3 out of 6 plus 3 out of 6 is 6 out of 6, minus 2 over 6 is 4 over 6, which simplifies to 2/3. Okay. Hopefully that makes sense. So now let's go ahead and just take a look at a couple more examples here, and then we'll talk about odds. So you might want to go ahead and pause the video if you want to take a look at anything we have here, because I'm about to erase the screen to give myself a little more room. So for this first one here, it says, a student is selected at random from a group of 200 students, in which 135 take math, 85 take English, and 65 take both math and English. Find the probability that the selected student takes math or English. So we want the probability of math or English. Okay. Well, to do that, this is going to be the probability that they take math plus the probability that they take English minus the probability that they take both. Okay? So first, the probability that they take math is 135 out of our total of 200, plus the probability they take English, 85 out of 200, minus the probability of both, well, 65 of them do both. 135 plus 85, that's going to give me 210, or rather 220, of course. 220 minus 65 should give me a grand total of 155 out of 200. Now, note that these share a factor of 5, so this becomes 31 over 40. Okay. Hopefully that makes sense to everybody. Now this next one here, a political discussion group consists of 30 Republicans, 25 Democrats, 8 Independents, and 4 members of the Green Party. If one person is randomly selected from the group, find the probability of choosing an independent or a green. Probability of I or G is the probability of I plus the probability of G minus the probability of I and G. Okay. Well, let's figure out how many independents are there? 8 out of, well, how many total members are there? 30 plus 25 is 55, and then 63, 67. So 8 out of 67 plus probability of green. Green is 4 out of 67 minus the probability of both. So how many are independents and green? Well, 0, right? There is no intersection here, so you can't be both a member of an independence or be a member of the Green Party at the same time. So we'll just add these up. 8 plus 4 is 12 out of 67. Hopefully these OR problems are starting to make sense. Now, the next type of problem I want to talk about are odds. So if we want to go from odds to probability, we're going to be making use of a given formula here, which is the probability of the event E. Well, if the odds are A to B, then the probability is A over A plus B. Okay? So let's suppose that they give you the odds are 3 to 1. Okay? Then the probability of E is 3 over 3 plus 1. Okay? Then this is 3/4. Okay? Now the other direction is, how can I go from probability to odds? Well, to do this, we're going to discuss the odds in favor and the odds against. So to find the odds in favor of something to occur, this is the probability of E, so that the event happens, divided by the probability of not E. Okay. Similarly, the odds against, that could be found by just the probability that the event does not occur over the probability that the event does occur. And that's it. Okay. Hopefully that makes sense to everybody there. Let me know if you have any questions or you want to see any additional examples. Otherwise, I will see you in the next video.